Today we will talk about limits. Let's first understand what a limit is. So usually you would have seen something like limit of fx, x tends to a. What does that mean? And fx can be a function of any type. Let's put it in a graph where it will be easier to understand. Let's say that a is here. So x can tend to a either from left hand side or from right hand side. If fx is a continuous function, like something like this, then we know that at this point fx will be fa. Doesn't matter if it approaches it from the left hand side or from the right hand side. But you might have a function where just for, let's say that for x greater than a, it is represented by a different function, and for x less than a, it is represented by a different function. Okay. So now what happens? When x tends to a from left hand side, we might have f dash x, and when it reaches from the right hand side, we might have f double dash x. So that is the whole idea of limit. So when we look into continuity, then we will see that why it is important. Just to understand a little bit better, just understand that the continuity is broken. And that's where one of the most important function of limit helps us in figuring out how continuity is out there. Okay, so let's do one thing. We'll figure out what are the different ways of finding limits. So the first one is direct substitution method. What does that mean? It's very simple. When you have to find fx, x tends to a, you calculate the function with x, putting the value of x as a. Let's say fx is equal to 3x square, fx, x tends to a, is 3a square. Okay, so many of these functions we can find the limits by doing the direct substitution method. And then there are like different things that you can do while doing the direct substitution. I will not get into the details of all of them. This you can already see from the book. So just for example, like when you have got limit x tends to a 1 upon gx, that is it becomes basically, so 1 upon gx is a full one, and it becomes limit x tends to a gx. So that way you can do the substitution for many functions when there are like more complicated formations out there. So let's just do an example to see how does it works. So we will look into limit x tends to 2, x square minus 2x plus 3, x square plus 1. So we know that limit x tends to a fx gx is equal to limit x tends to a fx limit x tends to a gx. If we take this one, this will become limit x tends to 2, x square minus 2x plus 3, limit x tends to 2, x square plus 1. You directly substitute there. So this will become 4 minus 4 plus 3, and this will become 4 plus 1. This will become 3 raised to the power 5. Okay. I will not do the full calculation, you can do that. Let's do one more, which is limit x tends to 1, log x4 plus x square plus 1. So in that case, limit, so log will come here, limit x tends to 1, x4 plus x square plus 1. This becomes log of, substitute, this is a direct substitution method, 1 plus 1 plus 1. This is log 3. Okay. Limit x tends to 5, 3. We know that limit x tends to a, k is equal to k. So this will become 3. So if it is a constant, the function is a constant, it will basically always give you a constant. Okay. Then limit x tends to 3, 4 of fx. This, and fx is x minus 5 ka whole square. So we do limit 4 we can take out, and x tends to 3, x minus 5 ka whole square. So it becomes 4. Substitute that, 3 minus 5 minus 2 whole square, which is 4 into 4, 16. Okay. So that's how you do the direct substitution. In the next one, we will look into the where the direct substitution method doesn't work, and we will figure out what we can do in those situations.